So when we talk about data sets, we also have to talk about how big they are and like what a model can actually work with. Um, so in the case, I should probably start this backwards. In the case of something like StyleGAN needs over 1,000 images to be able to accurately reproduce like the data that it's working with. So in the case of like the face data set that I showed last week, where you're able to reproduce fake faces, that was trained on something like 60,000 photos of other faces. That's a lot of photos, and the team that went to go make them and find them had to create like an entire platform to just collect all those faces. It was a very hard process for them. In general, I found that something around 1,000 images will generally produce a good StyleGAN data set. Now that's compared to Pix or Munit, where you can do like a decent amount less, but you still need like a bunch of images, right? And I'll go through this when I talk about models in a little bit. But essentially it's like less images, but still a lot. And then with Munit and Pix, you actually need two different folders, or like you need an A set and a B set. In the case of Pix, they're like very closely together, aligned. In the case of Munit or CycleGAN, they can be pretty different, but you still need to collect like good images of those things. So in case of something like horse to zebra, which I showed last week, you still need a lot of photos of good horses and a lot of photos of good zebras. And how do you find those? Like most of us don't have a collection of horse images and zebra images. So it's something to think about. In the case of next stream prediction, it's actually fairly easy because you just need one video. In the case of something like style transfer, you need a content image and a style image, and that seems fairly easy to do. So that's why you might see more people working in style transfer more often, because it's fairly easy to come up with a data set of that size. Whereas things like Munit, CycleGAN, Pix, StyleGAN requires a lot of data, and it can be pretty tenuous. It can be pretty like tedious to actually come up with all those images. Let's see. I want to check on how we're doing with time. Okay, cool. So taking about 10 minutes. That might be about in the middle of this model. We'll see how we go. So models. So we talked a little bit about like data sets and how that applies. I want to go through each model that we're going to show in class, work with, and actually talk about like what the model does with this data set to convert it to something else.